Hello, this is Muskan Singh, and today I am going to explain you the topic Moore machine and Mealy machine. Many kind of finite state machines have been developed to present as a computing machines. Up to so far we have seen that in case of finite automation, the output is limited to a binary single accept or reject, where the output is determined only by the state. This type of finite state machine is known as Moore machine uh, because E.F. Moore introduced this type of machine in 1956. If the output is a function of transition, the machines this type are known as Mealy machine. Now let's talk about Moore machine. The machine is of six tuple denoted by M is equals to set of I, S, O, S naught, F and G, where finite set I is of input symbols. Second, the finite set S is of internal state. Finite set O is of output symbols and initial state. So S naught belongs to capital S, a transition function. Next state from F uh, from function which is defined as S cross I belongs to S, an output function G such that S into I belongs to O, where O is output symbols. The Moore machine can be represented by transition table as well as transition diagram, similar to finite state automata. Now, Mealy machine. A Mealy machine is also a six tuple M. M is a set of I, S, O, S naught, F, G, and is a finite state machine where the outputs are determined by the current state and input. So ME is equals to I, S, O, S naught, F, comma G, where finite set I is of input symbols, finite set S is of internal state, finite set O is of output symbols, and initial state S naught, which belongs to capital S, a transition function from S cross I belongs to S, and output function G S cross S belongs to O. The Mealy out the Mealy machine can also be represented by transition table as well as transition diagram identical with Moore machine and finite automata. Now, what is the difference between Moore and Mealy machine? So, first, the Moore machine. The input of Moore machine depends on the current side. In Moore machine, if the input string is of length L, then the output string is of length L plus 1. The third point is with different input on the same state, its output is same. And the fourth point is Moore machine prints character when in state. Now let's come on Mealy machine. The first point is in Mealy machine the output depends on the current state and input. The second point is in the Mealy machine if the output string is of length L, then the output string is also, if the input string is of length L, then the output string is also of length L. The third point is with a different input on the same state, its output is also different. And the fourth point is Mealy machine prints characters on the same state, its output is also different. Now let's talk about the remarks. The first remark is two finite automata are said to be the equivalent if they accept the same language and produces same output string with the same input string. So two finite automata are said to be equivalent, means they are equal only if they accept the same language and the same output string, means both the automata should contain same language and produce same output string. The second remark is the Moore type can never be equivalent to Mealy type as the length of output string in is one more than from Mealy type for all same input. Here the length of output string is one more than that from Mealy type. So for all same input, so the Moore type can never be equivalent to Mealy type if this situation will arise. The remark third is the output depends on the present state, but it may or may not depend directly on the present inputs. Thus, the circuit whose output depends only on the present state is known as Moore type, while the circuit whose output depends on both the present state and the inputs are known as Mealy type. So in Moore type, its output depends only on the present state, but in Mealy type its output is depend on both the present state and the inputs. So these are the three remarks, and thank you.